The Hong Kong Zhuhai Macau Bridge is a 55-kilometer or 34-mile long structure consisting of three parts. The main viaduct, 29.6 kilometers or 18.4 miles in length, running through the Pearl River estuary. The Hong Kong Hub, 12 kilometers or 7.5 miles long. And the route of the Zhuhai Transport Hub, which is 13.4 kilometers or 8.3 miles long. The most significant structure is, of course, the main highway, a path almost 30 kilometers long, made up of the 22.9 kilometers or 14.2 miles surface bridge, which on its way to Hong Kong passes into the 6.7 kilometers or 4.2 miles long underwater tunnel. The tunnel arrives to the second artificial island, and the road goes back to the bridge, already in the jurisdiction of the Hong Kong authorities. This part of the path above the water has a length of 9.4 kilometers or 5.8 miles, runs into a coastal route which goes along the airport of Hong Kong and through another small tunnel, only a kilometer long.
Statewide Land Surveying, this is Patty.
Hey, I just had a quick question there for you.
Sure.
In any of your experience, did you ever have to take into account the curvature of the Earth?
I don't know.
Oh, are you a surveyor yourself, or?
Nope, let me get you one. Hang on.
Okay, thanks.
Greg?
Hey, Greg. I just got a quick question for you. I was wondering, in any of your surveying, have you ever had to take into account the curvature of the Earth?
For boundary surveys, not typically. So we measure or pretend that the world is flat. So if you see a distance on a map, that's the horizontal distance. The acreage is calculated by a flat plane. If we're doing GPS type stuff, that would be considered. There's a difference between a grid measurement, which is kind of a GPS measurement, and a ground measurement, which is your deep measurement.
Oh, I see.
For typical boundary surveys, it's not. They're a true flat plane distance.
Well, I see on your website that you guys do measurements over water.
We do a lot of hydrographic surveying, yeah. Currently, I have a boat out in the water right now collecting single beam data.
So are you
basically a GPS receiver hooked up to a survey grade echo sounder, streaming data through a box on the bank.
And you don't account for curvature and anything like that?
Well, the curvature of water would be water's flat, and this pond's only half a mile long. It wouldn't take into effect. The GPS isn't accurate.
Oh, do you happen to...
Vertically, GPS is probably accurate within only half to 3/4 of an inch consistency. Survey grade receivers.
Uh-huh. But do you know what the curvature formula is?
Portland? Not really. No.
Okay.
I could probably look it up. I mean, it all depends. The way we calculate it all depends on your height, right? Every height's different for the curvature.
Yeah, the eye height of the observer.
There's a big mathematical formula. You take the center of the Earth's radius times, I don't know it off the top of my head, but all the computer programs nowadays have that in it.
Yeah, it was just, they say that there's supposed to be, about in 10 miles, there's supposed to be about 66 feet of curve. That just sounds like a lot to me. That's why I was calling to see if you ever seen anything like that out there.
Generically, fishermen always used to tell me on the ocean, Earth curvature would start to take effect at 8 miles. I don't know how true that is.
Uh-huh.
Back in the day when I fished the ocean a lot, I would hear a lot of fishermen say that. I truly don't know, as far as sight distance, when a flat Earth, a flat ground like the Willamette Valley, when curvature would take, when you can start visually seeing it. I truly don't know that answer.
Okay, thanks. I was just calling to see if you'd ever seen any curvature out there.
Well, I mean, there is, but again, we mostly pretend we survey on a flat Earth.
Okay.
All right, buddy.
Thanks a lot.
You bet.
Bye. There you have it. They survey over a flat earth. And the only place there's curve is in the old fisherman's tales.
We measure or pretend that the world is flat. So if you see a distance on a map, that's the horizontal distance. The acreage is calculated by a flat plane. The curvature on water would be water's flat. The world is flat.